But yeah, hello Central. Looking extra cute. Thank you, thank you. Okay. Um, we're up on YouTube too. So someone posted this in my Discord, and I tried to do it yesterday, and I just couldn't quite get things right. This is really more of an engineering problem. Yeah, it was you, Central. um, Actually, wait. I wonder if this force is what was throwing me off, because this. What does that mean? Is that the net force the truss is applying to whatever is below it? I guess so. If you were to draw a free body diagram, well, no. Yes? The truss is at rest. And so presumably 450 newtons in would mean 450 newtons out. But the angle is a little weird. Hmm. Let me I was looking at this page about solving these things. And so I think like here they're saying that B has zero force, or rather, I guess BD has zero force because of the way it's set up with AC. Oh wait, or does it matter? Does the direction of the applied force matter? I don't know, man. This is confusing. How do they know the direction of? I guess if I guess you know they should be. I guess you know that DC should be opposing C, and that since DC has to push up, BC must be pushing down. Oh, okay. Hmm. Okay, let me. Am I smart enough to figure this out? Just big brain it. If I do this on joint B, which seems like kind of the most important joint here, uh, should I be? I guess I'll draw like that. That'd be a stupid way to draw the free body diagram. Terrible end. Terrible end. Well, it's not that bad, but eh. Um, I suppose BD should be opposing the 450 Newton force? Question mark? Well, I guess a combination of BD and BC could be opposing it, but I'm assuming at some point we should get to 0 for FBC. I just from the way this problem, or from looking at the trick on the page, I assume that's a 0 force joint, but hell if I know. And I guess AB, just trying to use common sense here, is going to pull away. Maybe? And so if I were to, is that necessary? Um, 30-degree angle there. 60-degree angle here. Terrible 0. That's not a 30-degree angle. I think I worked out before that this is also 30, so the entire thing should be 60. How did I go about doing that? That angle right there is 60. That angle right there is 60. Oh yeah, okay, so this entire thing's 120. 180 minus 120 is 60, minus 30 just leaves 30. Oh, what? No, what did I undid something. And I didn't mean to undo it. Redo. What? Oh yeah, okay, good. 60. So what pops out? Um 450. Now, I guess I don't know what that noise was. If I might even pick that up. Um I guess it's 450 should equal, because 450, like I'm thinking all the other trusses are opposing this force. Hey, Spetri. Oh yeah, you were doing problems like just like this at one point, right? I wouldn't blame you for forgetting everything. I sure know I have. Or I mean, I never learned this exact type of problem in the first place. I'm just trying to do this from like the general physics principles that I do know. Is that a cosine 60? I get the feeling that that is not a cosine 60. I feel like that's a sine 60. English mechanics is weirder than German mechanics? Really? Why is that? It's a terrible arrow, by the way. I, ugh, I'm gonna redraw that free body diagram. I'm getting confused with what arrow goes where. Hmm. Just the words. Technical English is not as intuitive at all to you. Interesting. I don't know if this is a good idea or a bad idea what I just have done here, but it is an idea. I feel like I might just be confusing myself even more though. Oh, hey Rob. Life's going pretty good. How about you? I'm sorry if you put that in a while ago. I was kind of lost in the sauce here. That should also be 60. That, that, why can't I draw? Or write? I really can't do anything at all, can I? Um, okay, but I guess allegedly these are both cosine 60 then. And FBD doesn't need any trig happening. I guess we also know FAB sine 60 should equal FBC sine 60. So really just those two forces should be equal. But if BC is a zero force member, that means AB is zero force also, and that just seems weird. And so maybe it's not a zero force member. Who knows? I sure don't. Okay. What about joint D? D is being pushed that way, and I guess pulled that way. If we have a net downward force, does the vertical component of BD need to be the same? You have a solution, Odie, if it's correct, though. It's whatever, it's probably going to be better than mine. I tried to do this yesterday, and I got some nonsense answers. And I have a feeling I'm going to do the same thing here today. Because I feel like this equality is problematic. Hey, Boz. Boy. What am I doing? Should I just... You know, I feel strongly that there needs to be some relationship like this, but I must be doing the trig wrong. Because the perpendicular forces do need to cancel. But FAB shouldn't equal FBC. That just feels so wrong to me. I must be messing up an angle. Hmm. I could be sneaky and try to re reverse Google image search this truss pit picture. Yes, Petri, if you have anything you can post about it, like please feel free to do it. There's a solution. Oh no, I don't have one. Um, the Discord thread is in the math homework help in truss calculations. So this is all the information that we have. This person was given a truss problem with no instructions on how to solve a truss. Apparently, Emma de shared kitchen simulator. Do you have roommates? Because if so, I feel that struggle. Um, I might try and dig up a solution here though, because I'm not feeling confident. I just took a screenshot. Share kitchen with 5 others. Oh my god. Terrible. Apparently Google say AI is good enough to read images and try to solve it. I'm not going to bother though. Let's see. 141 pages. You're not confident? No worries, dude. I appreciate you even thinking about it. Can we find this exact problem somewhere? What the hell is this, a leg? Oh yeah, it's a surgical replacement of a knee joint. Or can you imagine being a mechanical engineer and studying a freaking hook with ropes tied to it? I like applied math, but that's a little too. That's a bridge too far for me. I'm gonna okay. Control F truss. A gusset plate. Or yeah, or knowing what a word like gusset plate means. Only that's the only place where truss shows up in this. They are definitely applied math. Um, I'm just an elitist prick that looks down on things that I don't like. This is the same exact thing, isn't it? It's 114 pages. And I see more ropes tied to hooks. AB0, AC0. Uh, AB0, AC0. Wait, AB0, AC0. BC 450 plus cosine 30 times 450. BD 450. Interesting. Hey, GI, thank you for the work. Hmm. I could believe it. I believe a lot of things, to be fair, but you're saying BC is 450. That's 450. I shouldn't write here. It's a dumb place to write. BD is 450. CD is 450 cosine 30. Hey, Rushback. Um, ooh, maybe. To assert, yeah, I mean, like you could look at BC and CD as components of BD. If you were to look at BD, it's like, well, no, I'm not saying that right. Hmm. Wait, BC is the sum of the other two. Maybe I'm reading too much into that. I'm trying to figure out, like, if the net downward force is 450 newtons, which isn't a truss supposed to... I don't know what a truss is supposed to do. I shouldn't talk. It does seem like this extra 450 cosine 30 needs to be going somewhere. Like, something needs to be canceling it. Which I guess is what CD's job is. Hmm. I could see it making sense. I have a hard time with all of this, though, really. Yeah, it's hard. A rushback, I see you posted something too. Oh gosh. Is this another engineering problem? F4 should be 2160. I don't know I'm gonna know how to begin with this rushback. I'm sorry. Hey Edison. Wow, I never thought about analyzing like the clamping force of pliers like this. Um but considering I'm struggling just to solve this truss, I probably can't do that wrench problem rushback. I'm sorry, or pliers or whatever that tool's called. It's in the forum, just above it. Yeah, it's in for your physics. This is high school physics. I assume this. I guess you would use torques in some way. I have a hard time knowing. Like, I guess is that the fulcrum? Like, or is like I'm confused by what this piece is here. I don't know. Yeah, my physics knowledge is very minimal. I don't know. Yeah, I'll have to leave this one to Spetchy or anyone else who wants to attempt it. I think. So I'm not sure where to start with that one. To be honest, I think I've seen you around in Dr. Gold's chat. He would probably be better at this than I would. He should be streaming in a few hours. But yeah, unless it's someone from chat can answer here, I don't know that I can. Um. Oh yeah. So I was even with this trust problem, I've been reduced to just googling it. It's another. It's a 195 page PDF. Isn't that great? Show me your truss. You don't have a truss. If I can't find it in the next few results, I'm gonna just throw in the towel on this one. That's high school physics in Switzerland. If you gave that to a physics student in America, they would raise hell. Um, that and thermodynamics on our agenda. Are you doing like a college or a university level class? Like, is this like an IB class or something, or is this just normal ass high school physics for you? Just normal ass high school, bruh. Benjamin Payne, what do you have to keep in mind to take the picture from the problem and make a forest diagram like the solutions are showing? I'm not quite sure what you mean, but this is the original problem if that's what you're asking me to see. I generally know how to make free body diagrams, but I think I'm doing something slightly wrong with this one because it's kind of a situation I'm not really used to. You know what? I should say I don't know that he's streaming right this instant. He was streaming like a little while ago. Let me check. Oh, he is still streaming. Um, there's a new math and science help stream that I only found out about yesterday. Um, Fred, he's studying for masters in physics. He may know how to do problems like that rushback. I can't promise it, but that's another person who you could try too, besides Dr. Gold. Um, and he tends to stream like earlier in the day too, so might be better like time zone for you. You didn't get it. Um, I think I'm getting up on this truss problem. Okay, it's showing me real estate things now. Yeah, unfortunately, I'm just not gonna. I don't know how to do that problem. Um, yeah, Benjamin. It's I get the feeling that it's wrong though. Thousand-ish, somewhat in the thousands. That's the true engineering answer. Thousand-ish. Um, I think I'm gonna. I don't know. Do I want to do linear algebra or mechanics? I feel like doing linear algebra at least at first. Maybe I should actually look at chapter 3. Let me actually wait. I want to skim through the actual text of the chapter here, just for like some of these definitions here. You can ask it, Emma deploy. I'm not gonna promise I'm gonna try that hard to solve it though, depending on how it looks. Hey, famished. Are we doing well? Sent it in maths discussion. Oh God. Let's read it. I just see like how long it is. Good now. It's good to hear. Points P, Q, R lie in a sphere of unit radius centered at the origin O, which is fixed. Initially, P is at P naught 100, Q is at Q naught 010, and R is at R naught 001. The sphere is then rotated about the z-axis, so the line OP turns directly toward the positive y-axis through an angle theta. Sure. Okay, yeah. Position of P after this rotation is denoted by P1. Write down the coordinates of P1. Well, that's not... Okay. part 1 is a pretty quick answer at least. I'll bite. Generate to edit since you hit it while you're schooling, that leads to computer applications section. Okay. It's good to switch it up. This is a lot of words to say something that isn't that crazy. Basically, you have a point that starts at 100 on the x-axis, and you rotate it through an angle phi. And there's asking what the coordinates of that point are. So that's just some trig. P1 is the x coordinate should be cosine phi. The y component should be sine phi. And this would still be on the sphere. Oh, the best viewer bots are breaking through the auto mod. Getting paid $30 to edit a trailer. Ooh, nice. First thing looking at this question was thing I will not say yet. Okay. It's very cryptic. Sphere is now rotated about the line in the xy plane perpendicular to OP1. Okay. So this is the line OP1. The perpendicular line is there. And we're rotating about that line? Sphere's now rotated. But I think this perpendicular line goes through the origin? Is that what they're saying? So that the line OP turns directly toward the positive z-axis through an angle lambda. Is this constructing spherical coordinates? Is that what they're doing? Oh, I should fix my answer to part 1. I gave a two-dimensional answer. Okay. So I wish they said this explicitly, but I think they're saying that the perpendicular line goes through the origin, because that does change how this rotation works. So that should be a 0. That's the thing. That's the mistake I made in part 1. P2. How are we measuring this angle? We're measuring it from the xy plane from the wording. So you could think of it as like two different right triangles. One right triangle lies in the xy plane. The other right triangle, I guess, is just three-dimensional. But we're taking our old coordinates and putting them through another rotation that is basically, we're doing two-dimensional rotations. What am I saying? That would be I think each of our x and y coordinates are going to get multiplied by a cosine lambda. I'm going to write it out and see how it makes me feel. We could verify this against the, because I think we're basically deriving the conversion from Cartesian to spherical coordinates right now. So we can always check against what the actual conversion is. But this is how I'm feeling. I'm thinking this because the z component should be sine of lambda, because that's just the vertical component of the triangle, and that's exactly the z coordinate. And that kind of leaves just cosine lambda to go with the x and y coordinates. They should both be smaller. If lambda is very small, then nothing changes that much. Good. And if lambda is 90 degrees, we zero out the x and y components, and sine of lambda is 1. So I feel good about that. That checks out. I should be more certain to say P2 is that. And so I guess we have to find Q2 and R2 under these same rotations. Let's start by finding Q1, I guess. Seems like a good first step. Q1 is 0, 1, 0. It's right there. It gets rotated like that. It is the same as rotating P0 through 90 plus the same angle, right? So we could take our answer for P1 and add 90 to the angles. Which I think that seems like the simplest thing to do to me. And then let's use some identities to simplify those. So cosine theta plus pi over 2 is a left shift, right? That looks a whole lot like negative sine. If you take sine and left shift it pi over 2, oh my god. You get a peak, right? Which is just cosine. And 0 stays as 0. Okay. So then Q2. What happens to Q2 under the second rotation? Is it on the axis of the rotation? Can we say that? It should be, because it's perpendicular and it stayed perpendicular. Yeah, I think Q2 is the same as Q1. I think it's right on the axis. And I think we'll get a similar trick with R. Because R, under the first rotation, is on the axis as well. So that's not going to change. It will change here, though. I think it's the exact, and we can use the exact same idea. As before. We except it's perpendicular to P2 now. So we dig our answer for P2, add 90 degrees. And I think we're home free. Simplify all these. So we made the claim that cosine is going to become minus sine. We have two of the cosines, though, so just get positive signs. This is a linear transformation of an orthonormal basis, isn't it? We could there's a matrix interpretation here too, isn't there? Sine, we said becomes cosine. The cosines become negative sine. Let's lead with the no, we'll lead with phi. Sine becomes just cosine. Yeah, that's the thing that you weren't gonna say yet. Yeah, I know the two-dimensional rotation matrix, and I'm sure I've seen the three-dimensional one before. Um, I bet that we're basically deriving the... Actually, yeah, we're probably just deriving the rotation matrix, maybe rather than spherical coordinates. It is also related to spherical coordinates, but... You know, I don't like that I have part one up there. Like, it feels kind of lonely up there. There we go. It has friends now. Okay, part three. The sphere is now rotated for a third time so that P returns from P2 to its original position P naught. During the rotation, P remains in... What the hell? P remains in the plane containing P0, P... Okay. So we're up here at our three-dimensional points, and we're making a beeline right for home base, is what that plane thing is saying. Show the angle of this rotation, theta, satisfies that. Find a vector in the direction of the axis about which this rotation takes place. Okay. Interesting. So I do love some three-dimensional like visualization here. So this is actually I'm really liking this problem so far, Emma to blame. That's our phi. That's impossible to draw. Okay, let me draw phi a little bigger. Phi phi fo fum. Coming up out of here, we have lambda. And now we're asking about that triangle. Oop, not that triangle. That triangle there with theta. So this is a right triangle. Ugh. Angle theta, right angle. This bottom component is the the y coordinate of P1, which I said was sine theta, or sine phi, same thing. And the vertical component of the triangle. Hey, Dora, how's it going? The vertical component of the triangle is the same as our z coordinate, P2, which is sine lambda. So allegedly, tan theta is sine lambda over sine phi. Do I want to do that? We want cosine of theta. Should I do some Pythagorean type of stuff? I'm nervous to bring a square root into the picture here. Is there should be a trick, right? I want things with cosines, and I have sines. Chilling however the opposite of a light bulb moment is today. Did you lose a piece of knowledge? Is that what that is? You just emptied out your brain's recycle bin? Fred, thank you so much for the raid. I was lurking on you. For anyone who's here in my chat, check out Fred. I just met him yesterday. He seems like a super cool dude. He also does math and science help. Yeah, go and follow him. I hope your stream was good. Welcome in Die Fronty. I'm probably saying it wrong. Sorry. And Anti-Hater, welcome in. Oh, cool. Rush back. Franty? Okay. Yeah. Doing pretty good. We were asked this question from Amadablam. Where Amadablam said it's from a Cambridge maths admission test. And so we're just kind of doing this for fun. It seems like we're more or less deriving like a three-dimensional rotation matrix. I haven't really done this myself though, and I really like visualizing things in 3D. So I think I've answered part 1 and 2 adequately. I'm working on part 3. Cambridge Math step exam. Okay. I should do a better job of introducing myself for the people who are new. I'm Don. I do like math help streams like this, and in downtime I do some studying. So a very similar stream as what Fred has. The thing I've been studying in my downtime recently are linear algebra and mechanics. And on Saturday after next, so 2 Saturdays from now, I'm starting up a general relativity reading group, which I'm excited for. Yeah, Strang. It's not the one that I think I'm gonna do most of my studying from. I'm just trying to get back to the basics of linear algebra before I go on to like a more advanced book. But yeah, it's been a nice way. It's been so long since I've taken a linear algebra class. It's been a nice way to refresh my memory and yeah, just like fill in the gaps of stuff that my linear algebra class missed. But yeah, relativity reading group. And yeah, so another thing I'll say is that there's a whole niche of math help streamers out there. And the great thing, like we're all friends, we all hang out in each other's chats. It's a really like neat thing. Um, and there's a whole list of people who do math help in some way. So if you're interested in like this type of stream, this niche does exist, and there's even more people than just this. These are just people I've known for the longest. Hurdle was recommended by Dr. Cook, who's a regular around here, and he's a physics professor. So I just kind of trusted him on it. From what I can tell, it seemed like a good introduction. When I was just kind of Googling what people were saying about it. Suki, hello. How's it going? Good morning. Speaking of math streamers, there's one right there. Ian Stuckey. Relativity hype? Yeah, I'm really excited. Like learning about that little bit of special relativity as part of the E&M got me really hyped for it. Good morning indeed. Okay, for the problem on the screen, I'm working on part 3. Probably not helpful to this problem. This really looks like Euler angles or something we use a lot in spacecraft altitude control. Ooh, I'm curious to look up what an Euler angle is. Oh yeah, this sure looks like it. Yeah, I read through chapter 1 last night. I'm glad it was like as small as I thought it was. So it is a lot to say, like, oh, read 2 chapters in 2 weeks, but chapter 1 is just kind of, it's more to like get you interested in the topic, I think, than there being that much stuff to actually learn. The orientation of a rigid body. Oh, okay, so it's like a similar thing. Yeah, there's definitely a relationship here. Yeah, I can definitely see. I bet this problem's going in a different direction than Euler angles, but it's based on the same exact math here. That's neat. By the way, Dora streams just kind of like space talks. So if you're interested in that, go check out Dora. I'm trying to wake up earlier in the morning so I can actually like catch one. One of these days, I'm sure I will though. I've been having a bit of a degen sleep schedule. I mean, it's not that degen, but it's like slipping towards degen. Um. Oh yeah. Okay. So I had made this right triangle here, and I took the tangent of that theta. I don't know if that's the right thing to do. Maybe I should just go for the kill and take cosine. I just am not a big fan of bringing square roots into my life. If I could live a life without square roots, I think I'd be happier for it. So around 8 to 9 a.m. Okay. Usually at that time, I'm trying to draw the willpower to get out of bed. But to be fair, I am awake, so I should be able to. Alti, rotations indeed. Hope you're doing well. You know, hmm, so something is wrong, right? Like I need cosine phi and cosine lambda. I have sine phi and sine lambda. How do I get from one to the other? I don't think a Pythagorean type of thing is going to help me. Even in grad school, we just went rotate, pick a better coordinate system. Ugh. I mean, that's something I hear like Zach or Eats to Tway Pi talk about a lot. Where like, or even in like math, there's so many things where just a change of variables will fix everything. It's just like it's such a neat trick where it's the same problem, just in easier terms. What is cosine theta? Cosine theta. Ooh, it's the bottom part of this triangle I drew. What does sine phi equal then? Sine phi. Am I about to cook? I don't know. I'm looking at the triangle with angle phi in the xy plane right now. Phi cosine theta. This side here is something, right? It's not nothing. in lambda, in terms of lambda, it's cosine lambda. So I was doing Hamiltonian Lagrangian systems last year. This entirety some of it was convert to better coordinate systems. You can actually solve stuff. Nice. Wait, do these hypotenuses all have length one? No, like no e. Nope. The hypotenuses should all have length one. Um, yeah, sure, Mega. Run from Cartesian to alternate systems, often in terms of angles where stuff like the double pendulum was frequent. Yeah, or like I'm thinking of like when I was studying like E and M last year, like you would give the field for a charged sphere in terms of like r hat, whereas no, it's kind of always an r hat for a lot of these fields, right? Never mind. I'm thinking like you use the basis vectors that are most convenient. I'm having trouble thinking of the exact right example to give. Um. Ooh, I see why it's sort of multivariable. um. Give it the proof. Okay, I'll copy it down. Let me see if I can get through the end of this question here. That doesn't make an okay. I thought it just like deleted itself on me. The sign of the Jacobian cannot switch. Interesting. Ooh, I don't know. What does the Jacobian look like for R2 to R2? Yeah, I know for like if I guess if you're mapping. Wait, okay. If you have x f of x y equals z, the Jacobian would be like df dx. Is it second partials? I know what it generally like looks like this. I guess it would be a matrix of vectors. It's all first partials. Okay. Oh, I think of the Wronski maybe with second partials, but I know it's like a matrix of the partials in some way. Oh, Hessian. What the Wronski is something else then, dude. The determinant of a matrix has too many names depending on the context. And they all have eyes in them, or they're all like Ian's. Um, I was thinking about what it looks like for when it like maps R2 to R2 because I'm thinking like this is R2 to R1, right? It's just wrong. Figuring out functions are linearly dependent. Okay. Yeah, I think we're learning about like differential equations. Oh, use that for variation of parameters, right? Okay. Anyway, I'll uh I'm trying to make my peanut brain figure out part three. It shouldn't be that hard, but I need to get the right setup. I want to take cosine of phi, and I want to take cosine of lambda. You like the Ian's as a pithy name for lecture on the Jacobian, the Wronskian, and the Hessian? Yeah. I get them all mixed up. Ugh. And then even worse is for watching chess. Whenever I see the name Ian, I have to figure out whether it's Ian or Jan. It just adds a whole nother level of confusion. Um, you're not theta. You're phi. Uh, the Lagrangian. Oh no. Ugh. Hamiltonian, yeah, yeah. You're not theta, you're phi in Tired Voice. Was also heard a lot in grad school. Ugh. Dude, especially with how like mathematicians and physicists have different conventions for theta and phi, it's kind of terrible. Creative and unique username. Welcome in. Have you ever tried showing ChatGPT work and asking it to give you a hint or finish it off? I no, I don't really use ChatGPT much for myself, to be honest. Um, we've seen it's actually really good at math, or at least it seems uh it seems very good at math now. You should still verify it for yourself and think about it critically, but it seems like it solves some pretty difficult problems. Laplacian, yeah, we did see that. When physicists do math, it is terrible. First order approximations for everything. ChatGPT isn't good at maths. Literally just last week, it solved the composition integral that stumped me and everyone in chat for an hour and a half. And I didn't verify every step of algebra, but it definitely got the right end result. Yeah, I mean, I feel like it's just a thing where mathematicians and physicists can't get along. I mean, I don't know how physicists feel about mathematicians, but mathematicians definitely hate physicists. It's true. um, what am I doing? Not only in the problem, but also in life. Physics is just a branch of maths. No hate from me. Ooh, I wonder how they would feel about being called a branch of math other than their own thing. I don't know. I don't consider you like just a mathematician though. So I almost consider you like both though in my mind. See, I feel like you just like them both equally. But I mean, I agree with you though. I think they're both beautiful. Just are too concerned with formality, or really solving problems care about it much. Yeah, I had a crush on physicists. We bonded over a shared like of calculus variations for a short while. Oh, nice. Physicists a lot because they do a lot that I just can't hack. Yeah, pi equals 3, g equals 10. 2 4 is pretty rough at math for a reason. The new OL model got it to a pretty strong place. Interesting. Yeah, I mean, I'm definitely not saying it's false at math. I'm just saying I've seen it for myself do some pretty that seemingly correctly do some pretty difficult math. It might not do it correct 100% of the time. It might not even done that correctly, but it's better than it was when it came out, like undeniably, and it's only going to get better. Um, I'm also a dumbass who knows nothing about AI, just to be clear. Had a friend in undergrad who was a double major said that in one physics class they took a bunch of divergent integrals and just set a value equal to 1 and with their hands and said, when we do this, it gives the right answers. Oh no. Okay. Depends a lot on branch of physics, theorists versus experimentalists. Oh, true, Alti, yeah. And there is something called mathematical physics too, which is kind of a weird name to me. Like, what is non-mathematical physics? Imagine doing integrals by hand and just do it numerically. Oh my god. I really want this to be cosine lambda. It's just not, though. But haven't I done something wrong? Are all of these... Is the magnitude of this 1? I thought it was actual math that's related to things in physics. I did math. Okay. Oh, that's right. I remember seeing you say that at some point. Hey, Lucas. It's still kind of a funny name to me, though. Oh, yeah, yeah. Part 3 is definitely a step up in difficulty. Right, so I probably isn't that much harder, but I'm having trouble setting up the correct right triangle. The right triangle. Yeah, oh, Lucas, yeah. If I'm doing math, like always, and even if I'm not doing math, you can always try me. Mathematical physicists just go to both colloquia to get double snacks. Ugh. Oh, I know my problem. Do I know my problem? No, I don't know my problem. We gotta adjust our leg position. That's clearly the problem here. I wasn't like scrunched up in my chair. Yeah, sure. We can do that. Are you learning product rule? Wait, you're not even in calculus class. Why are you doing this? Yes, but no. Yeah, I had to think about it. Okay, want to show. That's like 3 weeks ago. What? Your class is all kinds of messed up. We're just gonna take a quick break from the problem we were just working on, because this one should be pretty quick. The thing we need to know is the product rule. Fg prime is f prime g plus fg prime. So if you want fgh prime, what we do is we pretend, I'm just gonna take, like, we're just gonna pretend that f times g is 1 unit and do the product rule with f times g as one thing and then h as the other thing. So when we do the product rule, we'll get fg in parentheses prime times h plus fg h prime. And now we can apply the product rule again to this bit here, because this bit here is just fine. There's nothing left to simplify besides getting rid of the parentheses. But this is another product rule. So I'm going to do parentheses because this h stays on the outside. Fg prime is f prime g plus fg prime times h plus, and then this term carries over, fgh prime. The only thing left to do here is distribute the h. F prime gh plus fg prime h plus fgh prime. Oh, were you doing it with limits? I would not use limits. That sounds terrible. I don't even know, kidding me? Or the knower. Oh, no, 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 no. Don't use limits. Like, use limits to prove this, but once you proved it, just use it. Like, you want to avoid the limit definition of derivative whenever possible. For the exact reason that you're saying there, it just gets really messy. Log differentiation. Oh, true, yeah. Using this will test you to your limit. Okay. So, assuming, let me know if you have another question, Lucas, but I hope that that's good enough for you. Oh, wait. Okay. You do have a question. Under, like, why do we know this? Well, maybe we don't know it. I was assuming that you have seen that before. Oh, under. Sorry, you did say under. Perfectly, I just interpret as to the side. Um, okay, so the reason I started here is just if you want to prove something like this, you generally want to start from one side of the equal sign and work towards the other. And the left side of the equal sign just gives me more to work with. Like we can figure out what this derivative is. Whereas with this, it's just kind of a bunch of things. It is possible, but it's harder to spot. So I just looked at the left side and said, okay, how can we make the product rule that we do know apply? And that's by pretending F and G are just one thing. Sorry. Oh wait, I'm sorry. And the we know only applies to like that line there. We don't know anything down here until we've like proven it and gotten to the end. If that's what you need. Like these are separate thoughts. Maybe that's what your question was. Tyler over in the YouTube chat looks like it says fight. Yeah, it kind of does. So H would equal G and FG would equal F to make the thing. Yes, exactly. The FG down here is the F up there. The H here is the G there. So it's weird because we're repeating letters, but that's the exact thing that we're doing. Why am I making my life so miserable? I've asked myself that, or I've asked myself the same thing many times. I guess so, Lucas. Do proving the product rule using limits is even just the regular product rule is kind of tricky. There's a weird spot where you have to do plus something minus something, and it's hard to know what it is if you haven't seen it before. So if you're doing it with like the three function product rule, I imagine it's even a harder thing to spot that's like that. But in the meantime, I'll wait to see what you posted. Oh, yeah. I'll keep on thinking about this problem here. Posted it? Okay. Oh God, Lucas. This is terrible. Yeah, you sure did use your entire paper. Ugh. Um, yep. That sure is limit definition of a derivative right there. Oh, nice. So I think that that is something like that plus and minus that you have to do there. I forget exactly how this proof goes. You factor out a g of x, h of x from the first part, and I guess an f of a from the second. I think you've already made a mistake going from, can you see my cursor? Yeah, you can. Okay. Going from this line to this line, I think the insides don't factor like that. It should just be g of x, h of x minus g of a, h of a. I don't think that factors. You know, this could have been worse, I think, but yeah, it is pretty terrible. You have the same first thought, Dora? How long do I stream, Edison? Normally like 3 to 4 hours. I don't have a specific goal though. Make a little mistake later on, which corrects it again. Okay. This could have been worse. The official motto of math teachers everywhere. Definition is a red flag. Um. Oh. There is a weird thing here where once you actually take the limit, um, shouldn't this be g of a and h of a? You want to get back to x though, which is kind of weird. I like we should end up with x's, but you don't care. Okay. And I guess that's f prime a, isn't it? Because it's the derivative at a point. Or no, is it f prime x? Like this, I should know this. No, yeah, okay, it's f prime a. But I guess literally you just take a equals x. Or you just let a be a free variable and just call it okay. It's not technically right, but it gets you to the right end result what you did in that part. Um, no, yeah, but this is you're gonna have to make another mistake in order to fix this, which I guess is what you said you did. Oh, what is this? Oh no, this is not linear work here. We're going all the way down here, and then we're later gonna come back up here. Oh my god. Yeah, I mean, I, I don't want to check the rest of this. As soon as you mess up this part, it's just all wrong. Like I would fix that part, and if you really want to do it, go from there. You probably are going to need a second plus something minus something, but it should boil down to just like I'm gonna tell you, just have a regular product rule proof, or the I'm sorry, not the left, but the right. Like this term over here, it should be just a product rule of G and H. You don't have to worry about the f of a. It can go outside. But I don't want to look at this anymore. That's why you work using intermediate steps. Yeah, and sometimes like simplifying is a trap, but you do like want to do that, yeah. Any tips on how to not overcomplicate shit? Uh, I mean, I do the same. It just comes down to how experienced you are with the thing. So just kind of keep practicing with it, unfortunately. Like, I'll get approved for something all the time, and then I'll look at the answer and realize how much simpler it could have been and feel stupid, but that's just kind of part of the learning process. It's the reason most lecture notes preproposition limits to build up a big result. Yeah, that and it like it it's just a helpful thing to know that in math it kind of like built on itself in that way, and you want to use things that you already know to the greatest extent possible. So if you're trying to prove an extension of the product rule, it's good to try to use the product rule itself. Um, I realize what my issue here is. I've drawn misleading right triangles. Um, I've been thinking like this is length one, that is length one, but if they're both length one, like this cannot be a right triangle here. That's where I have misled myself. Best lessons I've learned in uni is to know when to start over. Swedish we call it gora. I'm sure I'm saying it wrong. I just like to pronounce things anyway. Do it again, do it right. Yeah. It's like so sometimes I need to take like a day or two break from it before I do it right, just because I'm annoyed at it. But it is worth going back and doing it the right way. Um, okay, I need to do this right. I need to. What do I need? How? Okay, so I've realized my mistake with the right triangles. Basically, like the two-dimensional explanation for what I was doing wrong, looking at just the xy plane. If you take the point 1, 0 and rotate it through that angle phi, I was treating um this right triangle here the same as that right triangle there. And that's obviously not right. You get a different R2. Oh, that's a problem. Let's go. So I may, for the same reason, have misled myself with R2. that could be potentially why I'm getting the wrong answer here too. um, is it though? Hmm. Why wouldn't just slapping 90 degrees on my angles help? Oh, wait. Only lambda is plus 90. I I I think the fee is the same, only lambda is plus 90. Is that my problem? No, or even then, that's not the problem. Let's visualize this from scratch. I do think I'm all sorts of wrong. For R2. Um, we have the point 0, 0, 1. Oh yeah, Storm, it's up here. Under the first rotation, it doesn't move because it's right on the axis. And then it's going to move away through an angle lambda. So the z component, I think, is still cosine lambda. I feel decent about that. Um, but then sine of lambda is going to have, or the x and y component both contribute to sine of lambda. And we have to split it up, I guess, based on phi. Um, where is phi measured from on the backside? Uh, do, 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 do. Phi, I guess, is measured from the negative x-axis. So I think cosine of phi is still our x component. Cosine phi, sine lambda, sine phi, sine lambda, cosine lambda. I think I feel okay about that. Uh, the magnitude of R2 is 1. I did a lot in my head there. I need negatives, don't I? Hey, critical. It's a negative x and a negative y. I think I need to manually insert those. Okay, now I think I'm happy with it. I can try with it. You want to post it? I wouldn't just come right back around to the same thing that I had originally. I don't really remember what it was. Is this what you got, Penbox, for R2? Oh, you know what? I could have just taken P2 and done the lambda plus 90. Yeah, this turned out to be the same thing. Okay, 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 okay. Um, okay, but the right triangles are still freaky deaky. Oh God. Didn't you ask this to Gold yesterday? And it was incredibly long. Like I can say like what to do here, but I remember this problem being like multiple pages worth of work and incredibly easy to make a small mistake on. But they give you the solution to the differential equation are asking you to verify it. So what you would basically do is take this x, plug it in for that x, find the derivative of it, plug it into there, find the second derivative and plug it into there, and you should get 0 equals 0 or some type of true statement. But actually doing this and doing it right is really tedious. Like I think you're better off looking at the work that Gold did and just looking for where the small mistake was, because he basically did it. I mean, you could look at his VOD too, but I really like I'd rather not just like repeat all the same work for this one because it gets really messy. Yeah, Dora, that's the exact thing that you need to do here. It's just this is a product rule, and you take the derivative of it twice. So you get a lot of terms, and there's a lot of constants in here. Um, and so actual education was just doing the same problem yesterday, and I kind of don't really want to repeat it because it's really tedious and easy to make a small mistake on. I mean, I mean, honestly, okay, I we could go for that angle because I really hate just saying no. Like we could try to do the opposite direction and just solve it. This is a second order differential equation with constant coefficients, so you can look at the characteristic equation. Use a quadratic formula. They give us that the discriminant here is negative, so there's complex solutions. What would it look like? Um, since you're given this is a negative number, which is this thing right here, that's what that means. Um, I'm gonna factor a negative one out from the inside and just basically make it a complex number I. I think that's how you're supposed to do this. And so you can write it as a real part and a complex part. And so then the complex solution that needs to be simplified is a constant times e to the power of that thing with a plus. This is still actually going to be a lot of work. So I'll get it started, but I'm not doing the entire thing. I remember showing you the exact same thing before, actually. Um, the idea is use exponent rules to split up the e into two, like an e with a real exponent and e with an imaginary exponent. I'm tired of writing this thing. Okay. Ah, I don't have enough space to write this. Okay, and so the point here is that you need to use Euler's identity on those two things. E to the I theta equals cosine theta plus I sine theta. That's still going to be a whole mess of algebra, and I have done this exact derivation. I remember for a question you asked before, so I'd rather not go through it again. But this is an alternative way that you could do the problem too, and you should arrive to the thing here. No, it's this cosine plus I sine. Uh, Gamer, thank you for the follow. Oh, yes. Thank you, Dora. Great catch. T. These should all have T's on them. But yeah, I'm not gonna take the problem any farther because it still becomes extremely messy, but that's the idea of what you do. You're French and you love math? Oh, that's great to hear, gamer. Welcome in. Um, yeah, Storm is also French. There's a few French people who come by. If you're interested in math streams in general, I'm not the only one who does this. Here's a whole list of math streamers, and someone who um, just started back streaming recently. It's Fred. So there's a whole list of people who do math help. If you're interested in this type of stream. Yeah, welcome in, gamer. All right, Incredible. I'm leaving this problem here, but this is how you would Yeah, yeah, I can send it. There it is. I posted it there. No worries. You love the French chasu? Yeah. Plug it in. Yeah, like on these two exponentials with the i's involved, use Euler's identity and just try to combine things as much as you can. In Storm and Gamer, I don't mind if y'all want to have uh, a short exchange in French, but if you don't mind switching to English, because it gets awkward when I can't read my own chat. I do love seeing the other languages, but I also just can't read it. We just insult everyone in French. Très mal. No worries. Critical. And the thing that actual education was doing is equally as valid. I think they're kind of both painful either way. Yeah. That's like if I were to continue this, the next step would be to use Euler's identity. I just don't want to go through all of that algebra. Um, and Storm, the solution you put for P1, Q1, and R1, I think I agree with. I simplified the plus pi over 2's, but other than that, I agree with you. You gave me a formula, maybe I missed it. Oh, yeah, yeah. Um, chemical engineering, nice. So yeah, this problem that we're working on right now, I'm on part 3. Use zero coordinates. Yeah, I think the problem is basically asking you to derive like a 3x3 rotation matrix. I'm trying to do it the way the problem is like intending you to. Or at least I assume you're intended to do it this way. Maybe they'd allow like the linear algebra way though. This is from a Cambridge admissions exam, I think. Is what Amma Dublam said. And it's just a for fun question. I have been enjoying it. And I tend to scroll around, so if you want to copy this question for yourself, take a screenshot of it or something. Or it's posted in my Discord as well. Yeah, the matrix way would be a lot easier. I kind of enjoy working out this visualization though. So we do need to work out what theta is. Algebra is the best part of math. I don't know about that. I mean, for me personally at least. Algebraic topology. Oh god, yeah, I remember looking at the stuff you're studying, Storm. So I must be more careful about my triangle. The best part of math is probability. Ooh. You love random graphs. Interesting. You finally said what I showed you? Oh, good. I sure didn't. Percolation is the death. Ooh. The worst part of math? Oh no. You either love probability or hate probability with most people. My experience at least. Okay, so uh that right there, that is tan phi. I called it cosine phi or something, or sine phi before, but it's definitely a tangent. She just had the university, the interesting into Cambridge, the difficulties and the questions for the time. Oh yeah, if you have to, I will not be able to do this one quick, as you can see here. Hey Obi, hope you're doing well. Probability below physics? Oh, from Storm, that's a pretty that's like a grave insult. um okay, and so the height is um something times tangent lambda. It's the length of this hypotenuse, tangent lambda. That's what we want here. This is a very weird drawing, by the way. The length of the hypotenuse is 1 plus tangent squared secant. Oh yeah, duh. All right, you can just look at it visually. Yeah, it's secant phi. Okay. So, do we know? Okay, so we can take cosine of this triangle now. Secant squared? I think it's just secant. Am I crazy? Oh, no, it's just secant. Because 1 plus tangent, it's square root 1 plus tangent squared. Hey, Jed, yeah. But even then, you could just look at phi and say hypotenuse over adjacent, and adjacent is 1. So cosine of theta of the green triangle that's standing up is adjacent tan phi over hypotenuse, which is unfortunate. I sure hope this thing simplifies. That's what I'm hoping for. Bruh. Unfortunately, hypotenuse was my metal band in uni. um, is there a different expression for the hypotenuse? We could do the distance formula from R2 to P1. That's also the hypotenuse. Can I force this to look prettier, though? Can I just factor a tangent squared from the bottom? Like, if I just straight up cancel a tan phi, do I get a cancellation with the secant squared phi divided by tan squared phi? That could be something. It's 1 over cosine squared over sine squared over cosine squared. It's just 1 over sine squared. Okay. So that's cosecant squared. Phi. That's still terrible. It's the worst. If it was sausage, it would be the bratwurst. The play Proof or its movie adaptation. I never heard of it. Gamer, I don't see how that helps. With the tangent squared is cosine squared over sine squared. Might be my bad. Uh, ooh. There is technically a product to sum here, yeah. As terrible as it might be to speak of that. That's too much though. There should be a simpler way. Okay, what is the distance from R2 to P0 get us? I'll call it distance D. The x-coordinate of R2 is that. The x-coordinate of P0 is 1. 1 minus a negative cosine phi sine lambda squared plus P0 is 1, 0, 0. So the rest is just going to be the coordinates of R2. What do you do for me? Bring that all the way over here. Okay. I really hope you're not terrible. I would hate it if you were terrible. We can factor a sine squared lambda. Ah, yes, 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 yes. Factor a sine squared lambda from that. We get a 1 inside. So it's sine squared lambda plus cosine squared lambda, which is 1. So it's root 2 plus 2 cosine phi sine lambda. That's something. It's not nothing. The main character is a mathematician who starts dating a mathematician who is a postdoc who practically worships her father. Her father's mathematician Liz coming to Alzheimer's / early onset dementia. The guy takes her to a gig of his friend's bands. They do a song called I. Just stay motionless and silent for 3 minutes and 14 seconds. Oh no. What did I just do? From these two terms, I factored out the sine squared, which made the cosine squared phi and sine squared phi go to 1. And then I had a sine squared plus cosine squared lambda, and I made that also a 1. So then the 1 that this thing is equal to plus that 1 is 2. I don't think this is anything, though. Like, we could product to sum that, but it's not going to get rid of the square root, and we kind of have to get rid of the square root. It's not 3 because the first one we get is multiplied. You know why? Okay, cool, cool, cool. I mean, we can factor the 2 storm. I just don't know what we do after that. Like, what? How do we simplify square root 1 plus cosine phi sine lambda? The phi and lambda are independent. It's gonna play the movie. I had a friend who apparently did the handwriting shots for the movie since they needed someone who could write mathematical handwriting. Apparently, Gwyneth Paltrow stole her pen. Oh, doesn't surprise me. Probably above the mantle in the Goop Lab. When you can factorize, you do it. Fair enough. Um. This is so annoying. Should I be thinking about this differently? I'm working on part 3 of the problem here, Obi. And they can factorize, they do that even if it hurts them. The text was in French, it would be easier. Well, blame Cambridge, I guess. Yeah, the problem's posted in my Discord too, but if you want an image of it to look at for yourself, take a screenshot of it because I'm about to scroll around again. Um, what is cosine? Cosine of phi is 1 over the hypotenuse. All right, I think these are both dead ends. Yeah. And first engineering students are very creative. Sometimes they even admit mass, and you go around crushing their hearts. Oh no, Jesu. Yeah, I mean, English is my native language, and I had to really think about what they're saying. 2 pints tonight, probably too much given a lot I've been drinking the rest of the time. I mean, it just means that you get drunk for cheaper though. The more breaks you take. Um, let's help with mathematics. That's true. Nor 500 when I'm not streaming today. Oh, this isn't your normal stream time, isn't it? Fair enough, though. Forgot it's Tuesday. Just because I'm interested in promoting him, he raided me earlier, but there's been a lot of new people who have dropped in since he did raid. If you want more math and science like help type streams, go and check out Fred. He just started back up streaming last week, and he seems like a cool dude. So, he's a physics master's student in the Netherlands, if I'm remembering that correctly. So I forget you might do Monday and Wednesday math. Oh, okay. Yeah, I can use a hint here. I I'm sure I can do this. I keep setting it up wrong, I guess. It's one of those questions. Oh, do you get unfollowed Storm? Or maybe just because it's your other account? Either way, I appreciate it. Thank you for the follow. Oh, yeah, I forgot. Yeah, you used to have a different account. Show the right. Yeah, Jasu, it is. Like, we should start from one side of the equation and get to the other. Um, Dawn does meth. Mm-hmm. Well, yeah, I mean, I've tried that in multiple different ways, Jasu, and I keep not getting it. It's the issue. um, maybe I was going from left to right. Maybe let's try from right to left. I have multiple drawings, Storm. I need a better hint than that. What if I think about cosine phi tan or cosine phi cosine lambda? What if I start from the right side? We want to get to theta. So what's the shit between phi and theta? Better draw. Point taken, I guess. Yeah, yes, gamer. That's the question. Better draw. Hey, Phobos. Make a sphere and put your 3 points P, then draw the plane. I think I drew the wrong theta. I've been going after the wrong theta this entire time, I think. I think theta isn't here. I think theta is here from black to blue. Is that what I've been doing wrong? Oh my god, bro. Okay, yeah, Storm. I was visualizing in my head what you were saying, and yeah, you're right. This is a bad drawing. Oh my god. Okay. Fuck you, drawing. You're wrong, and it's definitely not my fault. It's your fault. Okay. What's actually happening? One B. Lambda. What? Excuse me. Um, Theta, in the way I've drawn it now, connects black to green. Which is a very different problem than the one I was trying to solve. You a Platist? As in like Plato? I think gamer means the Earth is an oblate spheroid. Like the Earth isn't actually a sphere. It's a squished sphere. Or it's a two manifold. You said to show local flatness. Oh, that's flat earther in French? Oh, okay. No, I'm not a flat earther, but I do think the Earth is made up of a series of triangles that are perpendicular to each other. Apparently. Problem is that at what point does a 100 nanometer sphere no longer be locally flat for simulation purposes? Oh, interesting. Plate, cube, sphere, it's the same thing in topology. The Earth made up of triangles, the internet is a series of tubes. Yep, Mega. You nailed it. Okay, is the right triangle here? Is that a right triangle? It'd be nice. I don't know that it's a right triangle, to be honest. Should we just do the dot product thing people were saying to do earlier? I want to do a dot product, I think. Um, we're gonna dot P0 and R2, right? And they're both magnitude 1. Because these are rotations of vectors of length 1. No, not R2, P2. R2, P2? Oh my god. I'm so stupid. Oh my god. I was using R2 also. I'm doing so many things wrong. Oh god, I'm done. Frickin'. Oh my, ugh. 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 Multiply those extra components. I cannot, no, not those X components, that's P1. P0 is 100. It's just, oh my god. It's a one-step proof if you actually know what you're doing. P0 is 100. When you do the dot product, you just get that X component, the other 0 out. Wizard Power, thank you for the follow. I'm glad you found my washed up stream. Welcome in. No, I'm very good at making small mistakes, apparently. Okay, yeah, Mega, thank you. This is crazy content. Yes, Emma DeBlame in chat gave me this Cambridge entrance exam question, and I've just been working through it. Playing video games? Fair enough. It was trivial. We have another part though. Yeah, we have to do this part, and I'm glad to have the verification, but yeah, I think the cross product gets us where we want to be. Okay, and this should be a relatively simple cross product. Not even I can mess this up. Famous last words. I didn't give myself enough room. I messed this up. This is probably taking me inexcusably long. We don't get an I component. We do get a J component. Wait. I'm managing to mess this up too. That's better. Lucked out, got to go to Cambridge without having to take the exam. Snuck in as an exchange student. That place is literal Hogwarts. Is awesome. Really? That's crazy. I thought that was gonna be some joke mega, but no. There's some JA advanced problems. Oh my god, Phobos. I'm already staring down the barrel of a proof from Megalomorph after this. And I see Papadoria is here. Hey, Papadoria, with a recursive function problem. Yeah, please do. And for anyone who's new around here, I dual stream to Twitch and YouTube. So if you hear me talking to like Papadoria, that person is in the YouTube chat. So that's why you're not seeing it. 1, 0, cosine phi, cosine lambda, sine phi. So I might put your proof on the back burner even further for Papadoria's question. But I'll still have it up here. I'm doing these determinants right. Sine phi cosine lambda k hat. Okay, I hope that's the right answer. The question asks aren't that difficult. Oh, nice. Kids' school looks like Hogwarts too. That's awesome. MIT has had an exchange program, so you got to go to Cambridge. Ooh, that's sick. What a nice excuse to be able to like travel. You didn't vibe with Cambridge, their natural science program didn't let you do math beyond 2 year. Oh, that's weird. Ooh, a Laplace recursive Laplace transform question from Pop. Oh god. It's an excuse to drop your CS double major because there was one course you really didn't really. What course was that? Oh no, okay, it's not actually Laplace transform, it's just the same character you're saying. Okay. Is that no wait. It's something like that. Paul has Laplace transform. This is gonna bother me if I don't see it. It's completely irrelevant. I could just make it a normal L. But it's gonna bother me. I need to remember this fancy. That's the fancy L. Why did that? What? Excuse me. What? Didn't I fix this? Evidently I didn't. Okay. Yeah, we're not actually doing Laplace transforms here. It's just the same character. Right, you can go to full screen mode in your browser. Oh yeah, I've used that before. Using Laplace transformation for the last 2 weeks. Oh, I think Laplace transforms were sick. 6.170 Java Development Death Lab. Rate is taking 18 hours a week. Students said it took 30 to 36. Oh my god, that does sound like a nightmare. Does the Laplace transform you don't think it would be possible? Probably not. I haven't read the problem yet, but yeah, our recursive Laplace transform seems weird. Okay. Let fancy L of X equal L1 of X equal 2x squared plus 2x minus 1. And let ln of x equal L. This is one of those fun ones where you can watch my script L's slowly degrade the more I write it. So it's a double composition? Or no, it's just, we're just composing polynomials. I assume there's some... I know that polynomial composition has some... It's significant in some branch of algebra or something like that, right? There's probably some trick. No, the Laplace transforms don't have anything to do with the question. I don't think. It's just the name of a function. Like, it's just the fancy script L. Oh wait, actually, what is this L? Oh, it's that L. Okay, yeah. But no, this has nothing to do with Laplace transforms. I don't think. You need to get set as horrible useful if you want to be a programmer. You don't have to go to grad school in math. Okay, so this thing isn't cleanly factorable, right? -1 storm. But yeah, it's just composing it over and over again. The same quadratic. So L1 has one positive and one negative root. Is the composition easier to do when it's factored? Getting PhD, you're going back for BSc in pure maths? Oh, nice. Change. Thank you for the raid. How have you been? You're playing Orion Will-O-Wisp? Ooh, nice. If anyone doesn't know Change, he plays a variety of games. We have a lot of crossover in our taste. So if you like my game streams, you'll probably like Changes. Thank you again for the raid. Defeated a spooter. The not intended way? Nice. I mean, it's always fun to find the not intended way of doing things. Don't know why you look up for your nappy thought it's gonna be a Donda's baking stream. um that's what you're playing right now, Mega? Oh, that's funny. Oh yeah, I forgot to ask you what you were playing. You have a crucial item touchability for the fight area. It was fun, in quotes. Oh no. Did miss today's lecture, so I don't know what we covered, if we covered anything about counting roots. Do we know of any root counting theorems or something like that? Well, the fundamental. Oh, I did drop the negative. Thank you, gamer. Yeah, the fundamental theorem of algebra is that there's as many roots as you have degrees, just that they might be complex. Um, an odd degree polynomial always has at least one real root. Yeah, that's a problem, Papadoria. Vieta's equations exist. I don't know if they'll be helpful. You know, I think I want to Google this. Hmm. This is a terrible answer, I feel like. De Craster's rule of signs? That's a what? Oh, Descartes. De Craster. I like that more. And Papadori's found the exact same thing. Um, oh, well, that just seems really convenient, doesn't it? I've never heard of this in my life. So you can always get the negative roots by just horizontally reflecting it, which is what this negative x thing is doing. Wikipedia actually giving an example? That's really rare. Wait, 2 or 0? Oh. Oh, this is only an upper bound though, right? Okay, yeah. Must be off by an even number, yeah. Okay. Famished, just my syllabus for introduction to programming. Oh, that's one of the classes where they try to teach you programming without actually doing any programming. I'm not a fan of that type of class. I think you should just start writing programs, like choose a language and use it. um, we got taught R. Yeah. See this month, so I get what I pay. Lx equals k is the solution for k and what? Then it comes to be equivalent to take 1 root of ln minus 1. So it being upper bound is potentially problematic. For ones who could do at the exam, you'll need to explain what the code does. I guess they didn't make you write code by hand on the exam, which I've been forced to do. um, so Descartes' rule of signs, just to test it on this one, there's one sign change from here to here, and it's degree 2. 2. This is 2. Um, so there's one positive root. That means there's one negative root. Okay, so that checks out. Uh, Now for L2, you're out of your storm? All right. Thanks for hanging out. See you later. And I did see what you were saying before, and I will think about that strategy. I just want to pursue this Descartes way first. Um, Can we figure out the pattern of what the sign changes must be? Thank you, thank you. It's kind of annoying. So, well, no, I don't know the pattern because it's going to get sketchier the higher degrees we get. This, I don't know how we can predict the number of sign changes for an arbitrary number of compositions. That's the issue I have with Descartes' thing. It's really neat. I can't figure out how we use it here, though. Using a textbook. Dude, that seems like a hard thing to write a textbook on. It just seems like a hard thing to teach in general. I really don't like that style of class. No, 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 no. Mega, it's only composition. I should just rephrase the question. Papadori was trying to say it's the fancy script L, is all. Like just that symbol is being used for the name of the function. I'm just gonna call it L. But it is just regular function composition. Hey, Badder? I don't know how to say it, but hello. Yeah, Papadori. I have not played Ori, no. Any of them. Or either, because there's only two, right? We're applying L over and over, not composing. Um, oh, I guess composition, as I was thinking, would be the other way. Like the n minus one would be on the outside. Is that? Because Beethoven's more easy than Hollow Knight. Yeah, I've seen it before. I just I don't know. It's never like struck my interest that much for a reason. You know what they will have if they don't have. Yeah, that could be rough if they don't use a textbook. Well, L of x squared, I don't know. 4.0 GPA, nice. Um, programming Arduino is use or not? If you're asking if Arduino program is a useful thing to know, it seems like a neat thing. I don't know that much about it though. Storm, you're saying it's the same? Okay. I'm gonna keep Storm. I'm gonna make sure Storm gets no sleep by just saying incorrect things about math. So that way Storm just can't like resist but correct me. I don't know. Mega Papadoria is just in a kind of a strange class. Like Papadoria's professor actually gave the class the Collette's conjecture as a problem to solve. It was like a bonus extra credit problem. So there wasn't a penalty for doing it wrong, but like without telling them, he gave them the Collette's conjecture. So it's a weird class with some really challenging problems. I don't even know what type of class it would be. Some type of discrete math class or something. Yeah, and it was disguised as well. Like you didn't even say, like. No, I'm not saying that makes you look dumb. I'm saying your professor is like ridiculous. It was a disguised version of the Colette's conjecture too. But yeah, no, I don't think that I don't mean that in a way that like that you're dumb. I just mean like your professor is up to no good. Recompile, run Java code. That seems more like it. Multi-threaded, object-oriented game application with the GUI. Ooh, nice. That's fun. Team classes will help telling him it was a troll. Yeah, I am a. Someone's having a great time. It's a nice thing to know you can do a lot of tiny things DIY with it. I had a fan. To activate with. Oh yeah, for our Arduinos. Oh, that's sick. Your professor is evil. Yeah, Papandoria. For all n and n, the sum of roots will be positive because a sub n over a sub 0 is greater than 0. So that looks like it's from Vietas. Um. Okay. But no, yeah. So just because we're just composing this quadratic with itself n many times. Um. So L2 will be a quartic. I guess L3 will be degree 8. Yeah. They're going up by powers of 2. There's a library for it. Use it. Unless you want to reinvent the real. Yeah, it does seem complicated. Am I a professor? I assume in stats, you mean? No, I'm just a tutor. I have a bachelor's in applied math. There's no way you found an answer online. Post in the Discord. Yeah, I mean, even if it's only L to the 2016. I definitely wouldn't mind looking at the answer that you found. Spoiler alert for the answer. You don't succeed. Yeah, you can't fall asleep when you have a problem in mind. Yeah. What? Excuse me? Okay, cool. Journal plus plus is slipping. Where did cosine of arc cosine of x come from? Oh god, I haven't read it yet. What? This is already we're already off to a weird start. Specializing group theory slash ring or slash representation theory. Ooh, okay. What? You can simplify cosine. Oh, with half angles. Oh my god, dude. What the hell? You could use I'm bringing the identity in. Like if you took that and applied cosine 2 theta is equal to, what was it? 2 cosine squared minus 1. I think you would end up with 2x squared minus 1. Now, how is this useful? What? You are not supposed to do it this way. How does the 2016 power get inside the cosine? And why isn't it also affecting the arc cosine? It's almost seems like I put markers through during my undergrad slash master's math modules. Oh my god. Sounds good, change. Thank you again for the raid. Hope you have a good rest of your day. Conjugation and the monoid of functions under composition. Oh, okay, interesting. This is not a realistic solution to this problem. I don't think. Got a class? Sounds good, Mega. Sorry, I didn't get to your problem in time. To be fair, though, I'm not sure how it started, so. But hope class goes well. Today was just 1 minute. Oh, it's tomorrow now for you? Okay, well, hey. Now have a good rest of your day. There you go. Gamer, at the beginning of something, cube x equals 0, have two solutions, r1, r2. Now for q squared, we want qx equals r1 or qx equals r2. To have, okay, yeah, and so I think that's the direction Storm was going in. Okay, this solution is crazy. I think let's try to find a more realistic one. Gotta get up early to keep writing my monologue. Oh, for like what you're gonna teach, Jasu? Um, so if we want to solve L of x equals 0, your thesis, okay, sorry. We want So plug in, we want this thing inside to be equal to a root. That's what you're saying? Yeah. It looks like a weird H. And so then the problem would become solving that. Oh God. What is the D'Alembert-Gauss theorem? I have never heard of it either, I don't think. Let's see. Oh, that's probably the fundamental theorem of algebra. Like, polynomial of degree n has n roots. K be a real number, let's solve L of x equals k. Discriminant. I mean, I don't I don't know what to do with this. Because I can see doing it for like this will get us the answers for L2. Oh wait, because that's no, I don't know. Oops, 2A. I I don't quite know what to do with this. Yeah, sure, Jesu. Computer guy, hey, how's it going? You need to do it for AK greater than or equal to -3/2, a variable. For a K greater than -3/2, a variable. I mean, it wouldn't be bad to know what the solution is by brute force, but it's not like It's not a solution that Pablo Doria could turn in. Bubba the cat. Oh, computer guy. I assume that's another account of yours. Thank you for following with it. Um, all right, see you, Dora. Thank you for hanging out. Oh shoot, and Papador, I saw your message and I didn't respond, but sounds good. Okay, so Papador, person asked a question, did leave, but uh, they'll watch it back. It's Bubba's account. Nice, nice. Gotta have an account for Bubba. Client just approved a large project. Hey, nice. That's great to hear. Um, you have to think about the same the sign of the root without knowing them, but thanks to the condition on K, it is possible. Well, by sunbathing, he'll be doing. Hmm. I think there's like two different versions of K because there's always two roots, right? So it's kind of weirding me out. I'll just follow along with what you're saying though. And the roots are looks like the Pythagorean theorem. Um, can you replace higher promote computation? So we know this is positive or zero, I guess. This could be negative or positive depending on K. Um, I I mean, it's going to be negative whenever root 3 plus 2k um, is less than 1. Wait, k is between minus 3 over 2 and minus a half? And k is a root. I don't know what you do with this. Because the power needs to get involved or the number of compositions needs to get involved here now, right? But I don't know how. If k is less than minus 3 over 2, no solution. If it's between minus 3 over 2 and minus a half, you have 2 negative solutions, and otherwise no negatives. You need to know where you at. Know in which case you are at each composition. Okay, fair. Meow squared. Oh my god. Oh, those aren't even like your emotes, but they definitely fit for Bubba. Okay, so we need to know where we're at for each composition. Hmm. And one k equals 0, you have one negative. For the minus, I'm already used to new tab emotes yet. Hmm. Fair, fair. Oh wait, well that's bad though, Storm, because we're saying, oh, else one negative. I thought it said no negative. Okay. Right, we always have at least one negative solution. Okay, yeah, I see. I see now. Okay. And so I assume then for L2, um, the plus gives us one negative, and the minus gives us two negatives. Yeah. Oops, I did that wrong. Two. But then we don't know what the k is for n equals 3 without like using some Wolfram alpha or something, right? What? Those are some funky roots. Oh, you. I should be looking at this at these roots. Yeah, okay. It's still kind of interesting. Like the roots themselves are. It seems like they have a pattern here, where we're just getting another square root to minus the previous answer. I guess the first three here are the negatives. Yeah. Oh yeah, yeah, yeah. It's a better idea. Okay. And so this is um we'll get two roots. Yeah, so we're getting two roots plus two roots, 0, 1. So 5? This like I doubt Papadori is allowed to do this part, but we can at least uh see the pattern's supposed to be. Wait, I didn't do that right. No, I think I did. No, wait, I did I? Oh, that's less than no. That's more than a half. It's 2 plus 1 plus 1. I forgot. We have the upper bound at minus a half, so it's 4. Yeah, so this isn't the technique we're supposed to use. I just want to get a couple of values though. 2, 1, 2, 1, 2, 8. It's a lot. I think that was 5. Between -3/2 and -1/2 is 2 negative roots. Oh, 5 instead of 4. I had 5 originally, but I thought I did it wrong. If it was 5, this would be Fibonacci. Potentially. Wait. Why is this different now? Oh no, Fibonacci needs a 2. Why doesn't this make sense? Don't these roots look different now? 2, 4, 6, 7. Why is that 7? I never gotten 7 but before. What? Am I stupid? Why? How's possibly the? One negative. Oh, I'm interpreting it wrong. Right? L2 is just 3. Okay, right. I think I'm interpreting it wrong. That's just 3 again. The actual number of negative roots. Oh wait, oh, more roots. It's cutting some off. 1, 2, 3, 4, 5. Okay, there are 5 roots for 3. More roots. More roots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, that's disappointing. No Fibonacci for us. But yeah, even then, this isn't the most helpful thing. to ChatGPT. Um, I'll put it into OAS. So 135811. There's way too many pages. Okay. I think I got a call on this problem. Uh, I I don't know what to do with this. You like it? I don't know if I do. Yeah, it's a good find a pattern to be in business, but I don't know what that pattern is. Um, okay, what we can do is type this up in Discord and see if someone wants to work on it more. Why would you do that to me? Just that's OBS's fault. Yeah. Hey underscore. Need. Um, some K. minus 3 over 2. Minus 1/2. You get 2 negative roots, and otherwise 1 negative root. Finding a pattern or where k falls for each composition. I made a mistake. Oh no. That sounds like me. A third? Here? No. Oh wait, 3k. It's 3k? Why is it 3k? No, yeah, I think this is right. Surely alcohol. No. Okay. I'll just leave that there as like a record of what we have so far, at least. Oh. It turns out negative 2 divided by 2 isn't a half. Bruh. We still have the same problem though, right? Like, we don't know how to find the pattern. But yeah, that is a stupid mistake. I just updated the thing I put in Discord. Solves a problem with Wolfram. I mean, these numbers I just got by like brute force. Not using K at all. They should hopefully be good. Verify with KT are the same. Okay, we can do that. Check our work. So this is using L2. So in theory for L3, we should have 1 plus 1 plus, no, yeah, 1 plus 1 plus 2 plus 1. So that's 5. And we do get 5 by brute force. Yeah, I think that works out, yeah. Dance time? 2, 3, 5, 6, 7, 8, 10, 11. Okay. Yeah, that... Should we have gone through 8? Did we skip over 8? At L4 is 8. Did I make an oopsie? See, I didn't realize at first that there's this more roots button, which did mess me up at first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Maybe I made a mistake on my table somehow. I don't know anymore. I think it works. I'm just getting all sorts of messed up right now. Just quoting Tim Curry. Oh, I don't know that reference. I'm gonna write Papadori message in the YouTube chat in case he comes back and checks the VOD. The Laplace transform never had anything to do with it. The only thing that it had to do with it is that for whatever reason, it uses the same script L. That's the only relation. See back from the grocery store. Oh, okay. Based on the board game. Oh, okay. Yeah, the only thing is that it uses the same L. That nothing else about the Laplace transform is related here. We do have this for Megalomorph. No, 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 no. Ask ChatGPT. I don't like using ChatGPT myself, so someone else is welcome to, but the inputs and outputs were functions of the same variable. Oh, because you thought it was a Laplace transform? Yeah. Okay, I need to remember what a Jacobian is. Because I was saying everything that is not a Jacobian. Hey, color cone. Uh, the sign of the determinant of the Jacobian cannot. What does it mean cannot switch? Like you can't swap two rows? Yeah, I am Colorblind. Hope you are too. Students find the absolute Jacobian from Cartesian to spherical. Oh yeah, I don't think the derivation is like that crazy. Oh, for every point in R2, it's always negative or always positive. Okay. If the map is 1-to-1, the sign is always the same. Um, to use Storm's setup here. That's the point of the point. Or that's the point of the proof, Jess. I'm just trying to figure out why when things get multivariable, they get harder to think about for me. What's the interpretation of the Jacobian? Yeah, like with critical points. It's like I just need to like the place where I see the Jacobian is with like finding critical points in 3 dimensions, right? I just want to find that. No, that's the Hessian to classify them. Oh, yeah, but the Jacobian is with the first derivative. That's the actual. That's where the critical points are. So the Jacobian gets you, right? Something like that. Actually, I don't know the language that you use to do this, but I guess I can get kind of intuitively that um the existence of a critical point means that it's probably not 1-to-1 in most cases. And if there's a critical point, there's a or like there's just a good chance that it wouldn't be 1-to-1. I think it's the idea, but I don't actually like say it in this context though. Um, I still don't know how to do that truss problem. I think I'm gonna find a linear algebra thing. Linear algebra problem. Actually, oh my god, it's already. There's no class tonight. Sounds good, Jasu. I might be about to call it right now, to be honest. Um, just debating. Yeah, I think let's call it because we don't have another question to work on right now anyway, and I feel like I'm starting to make more stupid mistakes. So maybe it's time. uh, so yeah, anyone who's here on YouTube, thank you for being here. I'll be back on YouTube on Thursday.